Hi everyone, this video is for lesson 10, which is bisecting an angle. We're going to start this lesson with this quick do now question, and it says in the diagram below, we have a construction of a line going through point P that is perpendicular to line M. So first, before we even go through the answer choices, we're going to answer the question, which statement is demonstrated by this construction? Um, so let's kind of just briefly review how you construct a line perpendicular through a given point. We kind of summarize it by first doing our smiley face, and then we do the perpendicular bisector. So we have our smiley face here, and then we have our 2 points of intersection, which would be right here and right here. And then you would take your compass and you would essentially construct the perpendicular bisector of this segment, but you only need to put your arcs below because you have a point on top. So when we do that, we would get an arc right here, and then we would flip it, and we would have an arc over here as well. And so, like this. Okay. So let's see if now we can answer this. So what did we do? So we did our smiley face, and we did the perpendicular bisector of that segment. So C1, if a line is parallel to a line, that is perpendicular to the third line. Well, right off the bat, we don't have anything parallel, and we don't have a third line. So it definitely can't be choice 1. Okay, choice 2. The set of points equidistant, okay, so equal distance, from the endpoints of a line segment is the perpendicular bisector of the segment. So I'm seeing some things like equidistant from endpoints, line segment, perpendicular bisector. So let's kind of pause. Maybe we'll go back to this one. 3, 2 lines are perpendicular if they are equidistant from a given point. Okay, so let's see if that's true. Here's my given point. Let's say point P. These 2 lines should be perpendicular if they're equidistant from this point. Well, that's a little awkward, right? Because M and then this line here, they're definitely not equidistant from the point. This vertical line is on the point. This other line is much further from that point. So choice 3, not looking so good. Choice 4, 2 lines are perpendicular if they intersect to form a vertical line. Well, I think I could actually probably draw something that goes against that, right? If I have this line here, well, it's not even a good line. Let me take my straight edge here, right? Here, and something like this. They're not vertical lines, right? They're still perpendicular. So choice 4, not so good. Let's go back to this one now. The set of points equidistant from the endpoints of a line segment. Okay, so here are the endpoints of this line segment. These points, so let's put point here. So it's saying that that point that I just drew in should be equidistant from here and here. So that means if I take my compass now and I measure, essentially, right, because we use our compass to measure, okay, and then I flip this around, and I go like this, my compass measure doesn't change, okay? What if I pick a different point? What if I decide to put the point over here? The same thing's going to hold true. My compass width wouldn't change. So from here to this point, there, is now the same distance from here to that point, right? So the endpoints of the line segment, if I take any point that's equidistant, they begin to form the perpendicular bisector of that segment. So we know that choice 2 is demonstrated by this construction. So this actually directly goes hand in hand with this theorem, and it's underneath. And here's the theorem. The theorem states that if 2 points or a set of points are each equidistant from the endpoints of a segment, then those 2 points, when connected, create the perpendicular bisector. So again, we're talking about having a segment, having endpoints, and saying that the points that are equidistant from those 2 points when connected would give you the perpendicular bisector. They're equidistant. If I connect, they would give me the perpendicular bisector. Now we know for sure that we can find the perpendicular bisector by creating the construction for that. Okay, so let's get into today's lesson, or the beginning of it. And in order to bisect an angle, we have to be able to name angles. So there are actually a number of ways to name angles. And the first way that you may or may not be too familiar with is by using 3 letters along the angle, including the vertex and 2 along the 2 different rays. So if you look here, our vertex is the point in which like the angle meets. So right here, P is our vertex. So what's important is if you're going to use 3 letters to name this angle, the vertex must always be in the middle. So I can name this angle RPS. So we have angle RPS. Okay, so that's one way to name this angle. Now we could also do this using the other letter S first, so SPR. So angle SPR. Okay, so that's using 3 letters. You can also name this specific angle just angle P by only the vertex. And the reason why is if I say angle P, your eye goes only to this angle. There's no other angle that I can name angle P here. So you have angle P by using just the vertex. Or the other way is by using a little number inside of the angle, right in the corner of the angle. So I could also name this angle 1. Okay. So that's the 4 different ways that you can name this specific angle. Remember, vertex is always in the middle, should you be using 3 letters. Something that I always like to do is if I'm using 3 letters, I say, let me trace. So if I trace from R to P to S, notice I'm going over that angle. But if I change it up, say I said, I don't know, RSP, way different angle. Okay, so you always want to make sure you can trace, and it should go right over your angle that's given. So with that being said, what if we gave you this question? Could you name this angle, angle P? And then why or why not? So let's go through this. Could I name this angle P? So if I said angle P, you would probably say, Miss M, which angle is angle P? Right? Because I'm looking at this and I'm saying, all right, angle P, is she saying this here, or the whole angle? So the answer is actually no. In a case like this, you cannot name this angle, angle P. And the reason being is because angle P would really give me 3 angles. So let's write that here. And the reason is 3 angles share vertex P. Right? The 3 angles that share vertex P would be angle RPS, angle RPH, or angle HPS.
Mr. Eichler, Mr. Ross, Ms. Ingelo, Ms. Schulteis, Ms. Dina, Ms. Trude, Ms. Baker, please come to the main office.
So I'm just going to go through them. We have this angle here, RPS. Then we have this angle here, RPH. And we have this angle here, HPS. So perfect example as to why you can't name this angle P. What I could do in a case like this is there's so many angles, I could actually put in this little angle here a little 1, this little angle here an angle 2, a little 2, right? And I'm even allowed to create a bigger arc like this and call that angle 3. This is the time where you probably want to use numbers instead of letters. Mr. Bronze and myself and Mr. Capel, we tend to put numbers in those angles just to make it a little bit easier. You don't have to worry about order if you're just identifying by an angle. Okay, let's continue on and let's actually discuss how we're going to construct an angle bisector. Now we've already done a perpendicular bisector, So an angle bisector, the whole purpose behind an angle bisector is we're going to create two equal angles. That's what an angle bisector is going to do. And it says here, let's discuss how we can finish this construction using these two steps. So first thing is we're going to bisect angle B. So at the end, I should have like a line going through here that's cutting this angle in half.
Ms. Carnadella, please come to the meeting office. Mr. Eichler, Ms. Tina, Ms. Baker, Mr. Walsh, please come to the meeting office.
So first, we're going to make B the center of an arc. So remember, my arc has to go through. So here it is. Okay. Label the points where the arc intersects the angle A and C. Okay, so I'm going to put a point here and here. Call this C. Call this A. So how could I now get a perpendicular? Get an angle bisector. So here's what we're going to do. 2 points of intersection, right? I'm going to take my compass and I'm going to measure from here to here. And now I'm going to swing an arc. Okay, and then I'm going to go and keep that measure the same. Take my compass, bring it down to C, swing another arc. My arcs are going inside because the angle bisector now is going to go from vertex B through those intersections. And there we have it. Okay, so that's how you're going to do this construction. I actually really like the angle bisector construction because it's pretty straightforward. So here it is. You make this B as the center of an arc, label the points where they intersect, A and C. Typically, you don't always have to label them. We're doing it in this first step. And then why don't you copy these down? You construct two arcs with the same compass width from A and C, and then connect the intersection of the arcs and the vertex with the straight edge.
Mr. Eichler, Mr. Walsh, Ms. Tina, Ms. Baker, please come to the meeting office.
Okay, so we go here, create an arc. There it is. All right, we have our 2 points of intersection here and here. Take my compass. Now you just have to keep the compass width the same. I like to just do it like this. And then I go here. And then here. And you're done. So really you can keep the same compass width through this whole construction. So the first arc that you make from B, make 2 more of those same arcs from the 2 other intersection points. And you're done. So now we know that these 2 angles are actually equal. So if I were to put like a little, say a little 3 and a little 4, I now know that these 2 angles are equal in measure, or these 2 angles are congruent. If 2 things are equal in measure, they're also congruent. Okay, so why don't you try this here, reconstructed angle bisector. So again, let's kind of work on this. And you know what? For something like this, you may be saying, this is awkward. Take this and just flip around your paper. Now we can do it pretty easily. Take it, get my compass, go to the vertex, open it up. Now watch how easy, 1 arc, right? Go here to the 1 intersection point, swing another arc. Go to the other intersection point, swing another arc. So 3 arcs the same width. Now I take my straight edge and I go from the vertex through that intersection point. We're done. Okay, so now let's look at the next question. And here it is. They want to know, is the measure of angle ABF equal to the measure of angle CBF? So essentially, are they equal? And if they're equal, or I should say, are they congruent? And if they're congruent, they're also equal. So let's go A, B, F, and then we have C, B, F. So are they equal? And you might be saying, well, I don't know. Look at the construction. What is this a construction of? It's an angle bisector construction. So we can answer this. Yes, they are equal because in the diagram, angle bisector construction is shown. This construction creates 2 congruent / equal angle.
Mr. Walsh, Ms. Ingelo, we're okay on the coverage. We don't need the coverage for those periods. Thank you very much.
And we're done. Okay, so you see the construction, you know you have two equal angles here and here. Okay, so let's move on and let's kind of try some application questions. So here's the first application question. Can you construct a 90-degree angle and bisect it? So first, how do you get a 90-degree angle? And in order to get a 90-degree angle, I need
Ms. Speaker, please come to the main office. Ms. Speaker, to the main office, please.
two lines that are perpendicular. Now they could be lines, they could be segments, they could be rays, but I need two that are perpendicular. Then how am I going to do this? I'm going to use the perpendicular bisector construction. Okay, so ready? What am I going to start with? I'm going to start with the segment here. And now I'm going to bisect the segment. So I have an endpoint here, an endpoint here. If I do the perpendicular bisector construction now, arc above, arc below, flip it around, arc above, arc below, connect. Okay, so I just constructed a 90-degree angle, right? So right in this little corner here, 90 degrees. Now I have to bisect it. I'm going to take my compass and I'm going to do the angle bisector construction, which we learned today. I'm going to shorten this up, change the color so you can see the difference. Okay, I'm going to swing an arc that goes through both sides of the angle. All right, keep my measure the same. Go to this point of intersection, swing an arc. Go to the other point of intersection, swing an arc. Excellent. And now connect as so. So what I actually created is a 90-degree angle, and then I created two 45-degree angles. This little angle in here is actually 45 degrees. And it was bisected, so this little angle here is also 45 degrees. That's how you get a 45-degree angle, and that's how you also create a 90-degree angle. Now, the next question says, hold on.
Mr. Walsh, I'm sorry. Could you please come to the main office?
Says, how could you construct a 60-degree angle? Now, this goes back to our equilateral triangle. In order to get a 60-degree angle, I need to do the equilateral triangle construction. How am I going to do that? I'm going to start with the segment, and I'm going to start my equilateral triangle. And if you don't remember, that's when I take my compass, make it the length of the side of the triangle, swing an arc above, flip it around, keep it the same length, go to the other endpoint, and swing another arc that intersects. Now, if I want the angle, I really only have to now connect my vertex, one of the vertices, one of the endpoints, through that intersection. And now I have here a 60-degree angle. From this, how do I get a 30-degree angle? I'm actually going to copy this, right? So I'm going to copy this and go here. If I have an equilateral triangle construction, how do I get 30 degrees from it? And simply, 60 divided by 2 is 30. So you do the equilateral triangle construction. I'm going to take my compass and I'm going to bisect this angle. I'm going to open it up, swing through, go here, keep my compass the same. This is when I really start enjoying this course because we're taking so many different topics or so many different lessons and kind of molding them into one construct all these different cool
Mr.
things.
Capel, please come to the main office. Mr. Capel, to the main office, please.
Okay, so now we have two 30-degree angles. One here and one here. And we're done. Okay, so that really finishes up how to bisect an angle and how to use the angle bisector construction to actually get a 30-degree angle, a 45-degree angle over here. And it's going to be helpful as we move forward in this course. Remember, this is a video, so if you need to, go back. You can rewatch any section. And if you have any questions, feel free to email.